so now we're going to take a look at an example of a one sample test for the mean, and we're going to have to decide, do we have the population standard deviation? Do we not? To determine what type of test do we have. So if we have the population standard deviation, if it's known, then we're going to use a z-test for a one population mean. So let's take a look at an example like this. So example 1 says, researchers studied body temperatures of healthy humans in an effort to determine if the mean body temperature of healthy humans differs from 98.6 degrees. In the study, a sample of 93 healthy humans had a body temperature of 98.1 degrees Fahrenheit. Assume that that sigma is 0.63 degrees Fahrenheit and use a 1% significance level. All right, so first up, right, my significance level is going to be 0.01, right, that's alpha. Let me move that just a little bit so you can still see it. I have, the second thing I'm going to do is just list everything out that I have. So we know it says a sample, right? So N was 93. I have a mean body temperature, so X bar was 98.1. Sigma, they said, right, was 0.63. So I have the population standard deviation, right? It is known. So we're going to use a z-test. Okay. So the third thing, right, is to write my null and alternative. So we're looking at the mean. They're comparing it to 98, right, 0.6. So 98.6 is my mu naught. And it says, does it differ? So it means the null would be equal to, the alternative would be not equal to. It would be a two-tailed test. Okay, so my fourth, fifth sort of step, you can draw your picture too. So your fourth step, right, is to find the standardized test statistic. So I have, right, so z, let me write it here, x bar minus mu naught all over sigma divided by the square root of n. So we have, right, I have 98.1 minus 98.6 divided by 0.63 divided by the square root of 93, right? And we want to put both of those in parentheses. So I have, put that in parentheses, 98.1 minus 98.6, close that parenthesis, divided by, parenthesis, 0.63 divided by the square root of 93. Here that over to find my test statistic. So I have, looks like negative 7.65, right? So if I were to draw my picture, let me draw it here. Here's my little picture. All right, this is sort of the p-value, right? We're getting ready for the p-value. So my standardized test statistic, negative, that's way, way over here, right? Negative 7.65. It's actually quite small. So what I need to do, right, for my p-value, so I'm going to do a normal CDF, right? Negative 9,999, right? It's the lower limit. Got a 9 there. My upper limit is going to be negative 7.65, mean is 0 and 1. And we will need to make sure that we multiply multiply the p-value by 2, since it is a two-tailed test. Okay, so let's see. Let me move my screen just a little so you can see the negative, right? So negative 7.65. Okay, so if I look, I will have at my let's see, second vars to bring up my normal CDF. I'm going to have negative 99,999. I'm going to have negative 7.65. Mean is 0, 1. Paste that. So it's roughly 0, right? And we times it by 2. We're still going to get 0. So we're going to get 0 for my p-value. So sixth step, right? 6 and sort of 7 is I compare, right? my p-value with my alpha. And alpha is larger, so that means we are going to reject the null. And so my last step is to write my conclusion, right? So my conclusion will look something like this. We could say at the 1% level of significance, the data provides sufficient evidence to conclude the mean body temperature differs from 98.6 degrees Fahrenheit. Right? So again, it just says that it does differ. It doesn't say what it is, but it does say differ. So this would be if I did it, I say by hand. Now, you can actually skip a couple of the steps, like step 4 and even a little bit of step 5, and just plug everything into your calculator. So I show you how to do this in case you need little pieces. Maybe you need just the p-value instead of everything. But if you need like the p-value, the standardized test statistic, if you go to your stat button and you arrow over to test, and we want the z-test, just the one z-test. We don't have the data, we just have the stats. So I have mu naught is 98.6. I have the standard deviation, right? Sigma is 0.63. I have the mean was 98.1. The sample size was 93. And in this case, our alternative, right, was the not equal to. The color doesn't really matter. We hit calculate, and you will see, right, I have my standardized test statistic. Now, my p-value, it does give me decimals, but if you look at it, right, it's to the -14th, which is roughly 0. And so this is a way without having to actually plug it into the formula, right? Steps 4 and really steps 5, we're not using this formula here, nor we're using the normal CDF. We can just use the z-test test on my calculator, and it will tell us the same thing. So you're welcome to use either method. They both should give you the same answer, just slightly different work.